Welcome to Eeci GATE's Biomedical Gate 22 solutions. So next problem also from analog electronics, little tricky, but once you apply your mind, you'll get the answer instantly. Okay. So you should not be surprised by seeing so many number of op amps in the circuit. You have seen such a circuit in a PID controller already. Okay. Electronic PID, similar to that, you have to treat. So it is given as a filter. Okay. A filter is designed by using 4 ideal op amps. Okay, yes, he used the word ideal. Yes, a filter is designed using op amps, resistors, and capacitors as shown below. Op amps are ideal with infinite gain and infinite bandwidth. That means ideal in all aspects you can take. So if V naught by Vi is an all pass transfer function, so that means V naught by Vi is a V in. Let me take of S. Okay, if you go for J omega, this is an all pass, so the gain must be equal to 1. That's what he mentioned. Okay, all pass transfer function, the value of resistor R2 is. So to make this modulus of your transfer function 1, what is the value of R2 in kilo ohms? That's a problem. So let us begin. So where to begin? So this is Vi. Okay, so let us play for the simple things. Okay, so this is V in. Let me take V in of S. So it's V in of S. Play with the V in shortly. And finally, we'll make it formally V naught of S by V in of S. Okay, so this is V in. Therefore, this is also V in. And this op amp is a simple inverting configuration, assuming all are in the linear mode of operation. So it is 2K, 2K. Therefore, this point is going to be, it's minus of 2K by 2K. So gain is going to be minus 1. Therefore, this output will be minus V in. Okay, a linear op amp. It's minus V in. Okay, so here what we have is, it is V naught. And what we have here is, it is going to be minus V naught. Because 4K, 4K, this is going to be minus V naught. A simple inversion is taking place here. So then we have to play really for the circuit and then for the circuit. Okay, so here the input is minus V in. Here the input is minus V naught will play. So then here the input is V in. Okay, so we'll take only 2 op amps. We'll comfortably go for V naught of S by V in of S. Then we can simplify the problem like this. So we have a resistor of 1 kilo ohms. Then we have a capacitor, inverting configuration. It's minus, connected to ground. So this point is V in of S. V in. Let me take, so it's 1 kilo ohm. So let me take it as, okay. So R, it's 1 kilo ohm. This is also 1 kilo ohm. Let me assign R is equal to 1 kilo ohms. So this is R. Along with that, I have one more 1 kilo ohm connected to the virtual ground point. Okay, this is R, and this point is connected to minus V naught as we determined earlier. And let me take this capacitance. C, that is 100 picofarad. We'll substitute this value later. So C is equal to 100 picofarads. Okay. So then what else? Yes, it's connected to the output. Okay. Yes, then it is connected to a 5 kilo ohm resistor. Let me take it as 5R. So this is going to be 5R. Because I'm taking R is equal to 1K. So 5R. And then another resistance of 10K. So I'll take it as 10R. So here it's another inverting configuration. So this is where we have our V naught of S, shortly V naught as of now. So this is connected to the ground. And here we have the contribution coming from, this is what exactly the R2 which we need to determine. That is exceeded by minus V. Okay, this point is known. So hereafter, this is the circuit to play with. Okay. So let me have a copy of this. If required, we'll use it. So now let us focus on getting V naught of S by V in of S. So this impedance we can take 1 by SC. Okay, so what is this then? So let me take this as Vx. What is Vx? It is due to two contribution. One is due to V in, another one is due to V naught. So then I can say Vx of s. Formally, this is V naught of s. This is V in of s. So Vx of s by superposition, it is going to be, so switch off this component, then you will end up with minus, it's okay. So Z2 by Z1. So Z2 is this, Z1 is this. So it's going to become 1 by SRC. So minus 1 by SRC into Vn of S you will get. Vn of S you will get plus what we get here is, due to this it is going to be V naught of S. It is again 1 by SRC, but instead of Vn we have V naught. Enabling this first and switching off this and enabling this and switching off this. Superposition simple. So then it is going to become plus V naught of S into 1 by SRC. Okay, let me go ahead, take this way. Okay, so two components, that's my Vx of S. So then what is coming as V naught of S will play for this. So V naught of S is equal to what means? So this Vx of S getting, assuming this is off, then the gain is going to be minus 2. So minus 2 times Vx of S I will get, and then switch off this Vx, you will get minus V in. So that is going to make another component that is going to be plus, because of inverting configuration. It is going to be 10R by R2, 10R by R2 into V in. That's what we are going to get here. So then V naught of S is going to make one more equation, that is minus 2 times your Vx plus 10 times your resistance R divided by R2 into V in. So we can substitute your Vx in this, then we can make a single equation that is going to be function of V naught and V in, and we look for the desired transfer function, which is all pass. Okay. So the next step. So this is your Vx. So let me substitute Vx in the next equation. So V naught of S is equal to minus 2 times your Vx minus 2 times, what is the Vx? Okay, so minus V in by SRC plus V naught of S by SRC. Okay, that is minus 2 times your Vx plus 10R by R2 into V in of S. That's all. Okay. Now let me make V naught of S is equal to minus, it is going to become plus 2V in by SRC shortly, and then minus 2V naught by SRC. Okay. So plus 10R by R2 into V in. So what I get from here, V naught of S plus 2V naught of S by SRC is equal to 2V in by SRC plus 10R by R2 into V in of S. Okay. So then take V naught of S common here. V naught of S is going to be 1 plus 2 by SRC. And here it has to be, again, take V in common here, V in of S. It is going to become 2 by SRC. Okay. Otherwise, I'll make it like 10R divided by R2 plus 2 by SRC. Okay. So now V naught by V in magnitude should be 1, means then 10 R2 by R2 must be equal to 1. That's a call. With that, we can complete the problem. It should be a all pass function. So therefore, we are demanding V naught by V in to be equal to 1. Okay. In fact, I expected something like how we play in analog electronics, like 1 minus SRC by 1 plus SRC. It didn't happen that way. Okay. Fine then. So then it should be 1. So this should be 1. That means these two should be identical, means it should be 1. Therefore, 10R by R2 should be equal to 1, so that it will act as all pass function. Okay. Fine. So then 10R by R2 equal to 1 means what is your R2? So R2 should be equal to 10 times your R. So R is already taken as 1 kilo ohm. So it is going to be 10 kilo ohm. That's your answer. Yes, a little lengthy, but still applying the fundamental, you will get the solution. And such a problem already happened in the gate 21. So therefore, I think you should have practiced well. So yes, connecting to this. Okay, little time consuming. So remember, biomedical paper scoring 50 itself is enough to get into the IITs. Okay. So therefore, this kind of problems always we expect, and still, okay, you can score easily even by attempting this little tough problems. Okay. So it is little time consuming, but still scoreable. Okay. Nothing else is there in this problem. So very interesting one. And the only surprise is the moment you see the problem, so many number of op-amps, you need to connect properly. And then you simplify. This is very easy to simplify. This is very easy to simplify. Rest you need to play. Okay, like this. Okay, that's a way to answer this problem. So hope you enjoyed this content delivered, and we'll update you with the next problem soon. Okay, so do subscribe our channel and look for further updates.